And this is another episode of 3D Printing News on Unpeeled, courtesy of 3dprint.com. So today, I'd like to speak a little bit about Flashforge. So Flashforge, as well, I was noticing on All 3DP, they had a sponsored post by Flashforge about their education offering. And they were saying that they had STEM certified 3D printers and special 3D printers for education. Flashforge is probably known as probably a company that got a pretty early start in desktop FDM, making clones and making printers such as Adventurer, and also making the Dremel and some printers for MakerBot as well. So Flashforge is a company that I think has a history in the space, and now we're seeing that they want to get this educational market. So I think this is a good play for them. I think the educational market is an entrenched market. It's a trend. It's a market that could be potentially very huge. And already, if we're looking at maker spaces in universities and print labs and universities and engineering faculties, it's actually quite a sizable market already. What I think is worth mentioning is the fact that, Ultimaker has an offering for education. We've got the Create Education Project and other kind of specialized education efforts. But I'm actually surprised how little is being done in education, how few lesson plans are out there, and how few, for example, in the UK, it's very difficult to certify materials, and you need to prove that your materials are not harmful, which is of course a very, very sensible thing to have. Why aren't there more guides on people helping to do this? Why isn't there a guide on helping implement 3D printers in the Swiss educational system or the Swedish one or all sorts of things like that? Why is it so limited? So I think this is just a huge market and potentially a very, very lucrative market, long-term market. Remember that Apple retrenched into the education market before expanding into the be-all company that it is now. So I think this is a good move by Flashforge, and it's emblematic of what happens with what's happening in competition. We've got the Anet, Creality, Artillery guys at the bottom end moving up. We've got BCN, Ultimaker, all these guys trying to move it towards more of the enterprise type of space. And there's this big fat education market that is really adjacent to the capabilities of 3D printers now, but they need things like better filtration, better safety, that kind of thing. So it would seem to be a good thing. And I was just really wondering, like, why aren't we seeing more education 3D printers, more education software, more education guides, and help to get people, to get going with education 3D printing? Just a thought. Okay, the next thing is kind of a metal plastic composites manufacturing method. It's kind of a hybrid manufacturing method, and allows you to make, as you can see in the images in front of you, allows you to make kind of parts that are either entirely metallized or partially metallized, or selectively essentially metallized, with an internal part maybe being metal and an external component being plastic. This has been done, this is based on work with researchers in Japan and Singapore. Professor Shinjiro Umezu, Kawai Song from Waseda University, and Hirotaka Sato from Nanyang Technological University in Singapore, or NTU. Waseda's in Japan. Now, this is a novel 3D printing method, a completely new 3D printing method that can really make circuits, robotic components, IoT type components, such as sensors, 3D circuits. Now, how it works is, initially palladium ions are added to the photopolymers, right? Then that material is made into a microstructure using DLP, or vat polymerization, where certain parts either have resin in it or the active precursor, this palladium stuff, that could be made metallized. Then, and this is the nifty bit, there is an ELP process, or an electroless plating process, that is used to selectively, essentially, electroplate, or an electroless plate, selectively electroless plate these models. And that means that in that solution, ultimately will emerge a part that is either a part photopolymer or part been ultimately metallized. They've been able to make structures in the millimeter range, also structures with like 40 micron in size. And they've been able to produce kind of circuit boards. If you see here, there's some of the examples of what they've been doing. The scales are visible. So they've been able to make parts that are partially plastic with a nickel part in the middle, for example. They've been able to make transparent plastic with copper on top of it. They've been able to put a nickel electrode on a substrate that's flexible. They've been able to put a metal ball, a nickel ball, inside of a plastic ball. They've been able to make flexible resins and flexible kind of like circuits or proto circuits or even like circuits where part of it, or part of the ball shape, if you will, is resin, and the other part is metal. We see on the next graphic, this is a kind of like, by the way, this is wonderful that Waseda and the NTU guys have given us so much graphics. Usually it's really difficult to find papers with good pictures that you can share. So this is actually wonderful. Um, so the selective electroless plating kind of method means that, well, what we're doing here is we're, on the one hand, the best photochemistry of photopolymers, which is being used for anything from your IKEA tables to a lot of other things, a lot of like resin printing as well. Now, advances in photopolymers, you could build on top of that, right? Advances in light sources like DLP, which is being used here, but not only in digital mirror devices, but advances in LCD and other technologies could also be used to advance this technology, and generally conveyancing and other kind of optimized solutions for stereolithography or vat polymerization methods generally could make this a more automated technology, because like the photo curing and all these other kind of properties and steps and washing and all this, that could also be used. So I'm extremely bullish about this. We don't really see a lot of novel technologies in 3D printing, and this could be one that has a wide application area, especially in circuits, and especially making a packaging plus a circuit and plus, making really kind of like circuits and 3D circuits, straight in one batch and one kind of production process, even though it's a multi-step process. I'm very, very excited about this, and I think you should be too. You should read the paper if you're more and more interested. And a new metal plastic hybrid additive manufacturing for precise fabrication, arbitrary metal patterns, and external and even internal surfaces of 3D plastic structures is the paper. And that's in ACS Applied Materials and Interfaces. So, hey, guys, check out that paper. It's really, really nice. I really, really like it. And tell me what you think. And have a great day. This is 3D Printing News Unpeeled with yours, Peels, and 3D Printing.